Okay, so here's the periodic table. And then if you already watched the coloring the periodic table video and did that assignment, good on you. You're already going to know some of this information. I'm just going to review it for the people that haven't watched that video. So remember that a column on the periodic table is called a group. So for example, this is group 2, 1, 2, because it's the second one from the right. Which group contains nickel? Nickel is chemical symbol Ni. So go ahead and look for nickel on the periodic table. When you see it, type the group number in the chat. What group is nickel in? Meg, are you back? Group 10, good. So we're all in agreement. Nickel's right here, so that means that nickel is in group 10. So that's good. Remember that a row on the periodic table is called a period. That's why we call it the periodic table. This is period 4, because if you count from the top, it's 1, 2, 3, 4. Which period contains phosphorus? Find phosphorus on the periodic table. Tell me what period that is. Got one answer so far. Got a few. Keep going, folks. Keep participating. Yeah. All right, good. So it seems like we're in agreement. Phosphorus, right? Yep. Thank you for everyone that participated. And so phosphorus is in this row. Well, this is the first, second, third row. Oh, whoops. So that says group 3. That should say period 3. In fact, you know what? I'm going to edit that right now just because I have time. This isn't going to be very long notes, folks. This should say period 3. Okay. Let me go back into present mode. We're going to be on slide 14. Good. So that's phosphorus. It's in period 3. Anybody have any questions on groups and periods up to this point? If you do, type it in the chat. Any questions on groups and periods? Okay. If you can do this, you can do the first half of the practice on your own. That's all we're really doing is identifying groups and periods. So this is what the periodic table looks like colored. This is, you should have done this already, but if you haven't, I put the assignment in today's folder. So take a screenshot and color your periodic table like this. Remember that this red group is the alkali metals. The orange one is the alkali earth metals. The yellow group is the transition metals. The green group is the post-transition metals. The blue group is the metalloids. This purple group right here and hydrogen over here are your nonmetals. The pink group is the halogens. And the black group is the noble gases. So take a screenshot if you don't have this already. Okay. So the orange, the red, the orange, the yellow, and the green group, those ones are all metals. Right? So the metals are kind of located on this half of the periodic table. So if you have that colored periodic table, it's going to be the red, the orange, the yellow, and the green. All those groups have metal in their name. Remember, these are alkali metals, alkaline earth metals, uh, transition metals, and post-transition metals. So these are all of our metals on the periodic table. Our nonmetals are on the other side for the most part. So it's going to be these ones over here. We've got our nonmetals, our halogens, our noble gases, and then hydrogen, which is also a nonmetal over here. So those are the nonmetals. In between the metal and nonmetals are your metalloids. Right? So that's going to be these ones right here. So if you know where your metalloids are, it's really, really easy to identify whether an element is a metal, a nonmetal, or a metalloid. So let's just go through a few examples. Is barium a metal, a nonmetal, or a metalloid? So barium is Ba. So see if you can find that one on the periodic table and then type in the chat, metal, nonmetal, or metalloid. See if you can find that one. Metal, nonmetal, or metalloid. Got one answer so far. Seems like we're all in agreement. Barium is definitely a metal. Look, it's right here. It's this orange one right here. So if you're to the left of this blue group, you're a metal. Does that make sense, Julius? So because we're to the left of this blue group, it's a metal. And so barium is a metal. Next, let's do silicon. Same thing. Find silicon. Decide if that's a metal, a nonmetal, or a metalloid. So silicon is Si, in case you don't know the symbol. So look for Si. A couple of you have answered already. Let's get a few more answers, and then I'll tell you the answer. So here's silicon right here. You can see silicon is in the blue group. So if you're in the blue group, you're a metalloid, right? So if you're left of the blue group, like barium, that's a metal. If you're in the blue group, you're a metalloid. Does that make sense? Julius, were you looking at sulfur? Because sulfur right here, that one's a nonmetal. It's sort of right next to it. But if silicon, since it's in the blue group, it's a metalloid. Okay, and so then last up is last up is oxygen. Is oxygen a metal, a nonmetal, or a metalloid? Yep, definitely a nonmetal. Look, here it is right here. And since it's to the right of this group, it's a nonmetal. So, just to review real quick, barium is a metal because it's to the left of the blue group. Silicon is a metalloid because it's in the blue group. Oxygen is a non-metal because it's to the right of the blue group. Does anybody have any questions? Okay, let's keep moving on. So we're going to watch this short video on the properties of metals and nonmetals. It's only about 7 minutes, and I'm going to skip some stuff at times. And then I'm going to let you go to work on the practice. Oh.
Metalloids. Today we're going to talk about the periodic table with respect to metals, nonmetals,
Can you all
and
hear
metalloids. All right, so here we have a periodic table. And you can see that it's divided into 3 different colors. So the colors that take up most of the periodic table are these non-periodic table. Ends up being a special case.
Right,
and
so we kind of
really
learned about
exactly
this.
what
The
to do with them.
nonmetals
So
are over here,
right now,
the metals are
call them
down
a
there,
non-metal.
and the purple ones are our metalloids.
Then I want you to notice that there is
Okay, let's fast forward a little bit.
Let's take a look and talk about that. Let's begin by discussing the properties of metals. This is a piece of gold that has been pressed into a thin foil. That's because many metals are malleable. Malleable means that they can be formed into thin sheets like this gold foil. We can also discuss being able to turn metals into wire. This copper is said to be ductile. Ductile means that the metal can be formed into wire.
So, properties of metals, you can pound it into sheets, you can shape it into wire, right? So, we call those properties malleable and ductile.
Metals are also good conductors. And we can discuss how they're a good conductor in 2 different ways. They could be a good conductor of heat, right? Like this frying pan here. The reason we use a frying pan is because we can heat it up with this fire and it transfers that heat very well to whatever we might be cooking. Or they could be a good conductor of electricity, right? And so we can see here that Pikachu is sticking a metal fork into an outlet, and he's going to get a good shock, even though he is Pikachu. Metals are also shiny, right? And we might say luster as another way to describe shiny.
So that's a word that will come up, luster. So if you see that when you're looking at the properties of something and it says that it's luster or lustrous, that means that it's shiny. And metals are lustrous.
Almost
they're
all
shiny.
solids, with the exception of mercury, at room temperature, they have high boiling points, right? It's because they are those solids, right? All right, metals, like these lockers right here, are also notoriously hard to break. So think about that. You wouldn't want to punch these lockers. It would hurt your hands. Metals are hard to break. We already knew that. So nonmetals are the exact opposite of metals. While most of the metals are solid, most of the nonmetals are gas. And the ones that are solid, like sulfur and carbon here, they're very easy to break, right? So we would say that those are brittle.
Right. So brittle is the opposite of malleable. Remember, malleable means that they're easy to shape. So, like metal, you could shape it into any shape that you want. If you try doing that to carbon or sulfur, they'll just break into pieces. And so that means that they're brittle.
So the solids are brittle, and most of them are gas. They are also poor conductors. Okay, we would say that they are insulators. So we said most of them are gas. Well, look, if we use these kind of cups to help keep our coffee or hot drinks hot. Notice what's in the middle of those cups right there, right? In this area right in here, there's just a space. There's just air in there, right? And that air, which is made of gas, is a good insulator. It's a poor conductor of heat. It keeps the heat in here and doesn't let it pass through, unlike the frying pan, which passed that heat through pretty easily. Okay? And they are also not shiny. So here's some sulfur here. It's pretty dull. The ones that are solid, carbon and sulfur, they're not very shiny at all. Metalloids are in between metals and nonmetals, both in characteristics and where they appear on the periodic table. So we say that there's that stair step. It comes right down through here. And anything that's on that stair step is going to be a metalloid. The one exception is aluminum, right? Aluminum, while it's on the stair step and it appears like it would be a metalloid, think of
You guys don't need to know this.
it is, so it's giving you all the antimony, tellurium, polonium, these and nonmetals. Silicon is a perfect example of this. Properties of both metals and nonmetals are metalloids. Now, metalloids are going to share the properties of both metals and nonmetals. Silicon is a perfect example of this. And the very fact that you're hearing my voice and watching this video right now is because of silicon. Silicon is a semiconductor, which means that it is both a conductor of electricity and not a conductor of electricity. We can control that. And because we can control that, we can send information on, off, ones and zeros in a binary code. Well, this is how computers work in this binary code. So if we didn't have semiconductors that were in your phone or in your computer, then none of this would be possible.
So a semiconductor is just something that kind of conducts electricity, and that you can control how much electricity it conducts. And so silicon, which is a metalloid, most metalloids are semiconductors, which means that they, like a metal, they conduct electricity, but also like a non-metal, they don't conduct electricity. So they're sort of like in between. And that's kind of how I want you to think about the metalloids, is they have properties that are kind of like a metal, but also kind of like a non-metal. There's only a few questions on the properties at the back, so we're going to go over those tomorrow. If you're confused,
you wouldn't have an
about all of
iPhone
this.
Or a Galaxy. It just it wouldn't happen. So you are a huge fan of semiconductors and metalloids. In summary, the periodic table is made up of...
Okay, good. That's all we really need to watch on this. So, actually, you know what? Let's watch the summary.
Elements that we classify as metals, nonmetals, and metalloids. The metals are located on the left of the stair step, and they make up most of the periodic table. Metals are mostly solid. They're often malleable, which means they can be formed into thin sheets. They're often ductile, which means they can be formed into wire. They are good conductors of heat and electricity. They're often shiny and difficult to break. Nonmetals are located on the right side of the stair step. Most of them are gases. The ones that are solid are brittle. They are dull, not shiny, the exact opposite of the metals. They are poor conductors of heat and electricity. We call that property, they are insulators. Metalloids are in between metals and nonmetals. They are located along the stair step on the periodic table, with the exception of aluminum. Aluminum is the one that doesn't follow that rule. It's a metal, but it is along the stair step. Metalloids share properties of both metals and nonmetals. And we talked about silicon as an example. It's a semiconductor, and that property allows us to use it in electronics.
Okay. So try to complete the practice for today. It's in today's folder. Does anybody have any questions on properties of metals and nonmetals? Anything that they're not understanding? Okay, go ahead and do the classifying elements practice then. It's an assignment in Notability. Complete the assignment. Go ahead and submit it to Schoology. If you do have questions, hang around in the chat and I'll answer them, okay?
I have a quick question about the test from yesterday.